Hello everybody, this is Mike Bartles from the Hydrologic Engineering Center. This video is a recording of a webinar which took place on October 17th, 2023. Within this video, Avital, Breverman, and myself present the newest version of HEC-SSP, talk about the updated tech transfer materials that accompany this release, provide a demonstration of several new features, and talk about the future of HEC-SSP. Enjoy! First things first, bonus points if you know what damn this is. Be very impressed. This is a picture given to me by my buddy Eric Deshansky. So it is in the Tulsa district, but let me know if you know where this dam is. All right, today I promise we won't PowerPoint you to death. I'll go through a little bit of PowerPoint, but we'll get out of that relatively quickly. We're going to talk about the tech transfer materials that we have updated and made available to support the 2.3 release. Then we're going to show you new enhancements, right? And we're going to jump out of PowerPoint at that point. We're going to do a lot of demonstration. We're going to save time for question and answer at the end, but definitely throw stuff in the chat right now as we go if you do have questions, and we'll get to them when we can. SSP is a team effort, development and support of the actual application. So there's a lot of us that actually work on this, and definitely want to recognize them. Matt Fleming, for instance, he was the Hydrology and Statistics Division Chief up until recently. He is now the Water Management Systems Division Chief. So if you are doing anything SWIMS related, you'll probably be talking to Matt, but he's still super knowledgeable when it comes to statistical hydrology. So he'll still take your questions and probably pass them on to us, but he's a great guy. Beth Faber's also been around since the beginning of HEC-SSP. If you've taken any of our courses to do with statistical applications, you've probably gotten those awesome lectures at the beginning where Beth gives you an introduction to stats and brings everybody up to speed. So thank her for that. Greg Karlovitz is the acting H&S division chief here at HEC. He is a statistical guru. So if you have like nitty-gritty questions like, I want to know how this actually works, Greg knows how that actually works. You can hit him up. And Avital is our recent excellent hire from Colorado State. So everybody say hey to Avital. She will take any and all questions as well. All right, latest version is available from our website. We have updated our website. 2.3 is available. Do not grab the setup package, the regular one, if you are on an ACIT machine. Use the portable package. You do not need admin privileges to download or use this version, right? So don't worry about having admin privileges. Don't get the setup package. Grab the portable package, this guy right here. Don't extract to your C users profile, so not to your desktop, not to your C documents, whatever, downloads, whatever. Put it in like C mic programs or something like that, and it'll work just fine there. ACIT locks down your C users profile from actually executing any jars or executables or DLLs, so don't do that. But hit me up if you have any questions, and I'll walk you through it. Tech transfer has taken a lot of our time recently. We do this because we would like to support our software and not just say, here's the application, have fun. We show you how to actually use the software, right, as part of all these documents that we put up on our website. And we have migrated everything to our website. Confluence is down at the moment. We know, we are aware of it. Avital has been getting many panicky emails lately, mostly from outside the core. So I'm thankful for the core folks from being restrained. We're working on it. We'll get it back up soon. But all of our documentation is online. When that's back up, everybody, all these links will work. Go ahead and click on these links and you go to where you need to go. As part of like the documentation that we put up there with like users manuals and stuff like that, we also have all of our training materials, webinars that we've recorded in the past. So they're all on YouTube, in addition to conference materials. The users manuals users manual is just one part of the documentation. We also include release notes, which is like a quick snippet of here's everything that's important about this release. Here are links to further information. We also distribute a ton of examples with the software. So examples are included for every single aspect of the software as well. And we give you step-by-step instructions on what to do with them and how to compute them and view the results and everything on this examples link here. Tutorials and guides are where we spend a lot of time. So these are meant to be easily approachable examples that everybody can follow. They're not academic in nature. They're easily relatable. So trying to get through the nitty-gritty very, very quickly down to what is most important is our goal within the tutorials and guides. So definitely check those ones out. More to come on that in a second. If you're interested in following our computations and how we validate the software, we also have a validation guide as well. All right, training materials. If you come to any of our classes, you will likely see something like this as well, or use this as part of the class. The thing on the left there, the image that I'm showing on the left, is a screen cap from our statistical methods in hydrology class. So we'll have you go through and click on individual links to get to workshops and stuff like that, but we make this available to everybody. So if you miss the statistical methods in hydrology class, if you miss the flood frequency analysis class, if it's been 10 years since you had either one of those and you want to just get a refresher before you get back in person to our classes, feel free to check these out. We also include links to YouTube videos where we give these lectures, usually much faster than we do in person, in about 5 to 6 minute snippets. So go ahead and check out those videos as well, and we have them all linked as playlists over on the side as well. As part of the tutorials and guides and training too, we do more than just HEC-SSP as part of statistical methods in hydrology and flood frequency analysis. For instance, we do a lot of applications with R in our studio, right? Avital and Greg did a really great workshop for the Los Angeles district where they also used R to analyze partial duration series. If you're interested in learning how R works from a statistical hydrology perspective, we have tutorials to help you there as well. Finally, the webinars that we do have posted on our website go into much greater detail with specific topics. So I'll talk a little bit more about this in a minute and show you expected probability, but if you're interested in hearing an hour-long lecture or demonstration of expected probability, Dave, Margot, Beth Faber, and myself gave a presentation on that last year, and that's available on our website for you to go and check out. So lots of good material there. Definitely want to highlight this great presentation that Landon gave, Landon Erickson from the Fort Worth district as well. We have that one posted on our website, as well as previous materials. So if you missed today's or you want to go back and check out today's webinar again, we'll also post that there too for everybody to see. All right, here's where we leave PowerPoint. No more PowerPoint, I promise. All right, we're going to get straight into demonstration. I want to show you the individual bits and pieces of 2.3 that are of interest. We're not going to be able to get to everything, but we're going to try and get through a whole lot today. So first things first, I want to create a new study, and I want the study to go here. I'm going to call this HHC COP demo. Don't worry about changing the other settings. We'll just let those ride as the defaults. Now that I actually have the application open, I can add data. I can do all sorts of other things. Oh, before I go very far, any further, I'm going to show you guys the help menu. These are live links to our website. So when Confluence is back up and you don't remember the URL to get to the documentation, feel free to go to help in the software, help, user's manual, tutorials and guides, examples, training, whatever, and that'll take you right there. If you want to install the example data that I was talking about earlier, so all those examples that go through every piece of the software or every corner of the software, check out install example data as well. If you would like to get to our discourse page where we answer tech support questions for everybody to see, go ahead and do the About HEC-SSP link and click on HEC-SSP discourse, and that'll take you here as well. So if you'd like to see what's going on, how people are answering questions, who's asking what questions, definitely check that out. This is like Stack Overflow for HEC. All right, now that we have that, go ahead and download some data first. We have buffed the way in which data is incorporated or ingested within SSP. You're probably used to, if you've used it in the past, this traditional import in here. If you'd like to go fast, you can still do this. However, we've added a wizard to make you go a little bit slower along the way. So we found that people were having problems later on, and it all stemmed from improper data entry. So we broke that step down into various bits and pieces and added that to a wizard. And we're going to access that by right-clicking on data, going to new, and using import wizard. You can also go through the menu up here at the top, but I like to right-click, so we'll get there. The name, description, and short ID are optional. You can add them if you would like. Don't worry about it. If you don't want to, it's all good. We'll give it an auto name. You can change it after the fact too. I do want to import a time series, and I don't need to enter metadata. That'll come along with the actual data. I want to actually grab something from the USGS website. So I'm going to select that as a data source. We have 4 other data sources as well. I'll show you some of those in a second. Go next, and now I want to get annual peak data. I really like these stations in Missouri that I found for the last NWK webinar, so I'm going to go with those ones for a second. And I queried IDs for the state of Missouri, so I found 538 gauges that have ever been in operation with annual peak data in the state of Missouri. Right? I can do multiple states, so if I click this again, do Kansas, do this again, do Nebraska, whatever. I can start to chain together multiple state searches. But now that I got all these IDs that I want to find, I found here, now I have a table of all of the locations, those 538 locations. You can manually go through and click on this if you would like to, but you can also use the text fields at the top to search for things. Wildcard character star helps us narrow things down. So say, for instance, I want information for the Platte River. I'm going to do star, Platte, star, hit enter, and now I've filtered down this table to just show me the locations that have the string Platte in it, which is great. I want these 3, right? If I wanted to find every single station along the Missouri River, this is how I would do that in the state of Missouri, right? If I wanted to do it for every single state, I would search Montana, I would search North Dakota, South Dakota, Nebraska, Iowa, so on and so forth, the whole way down to the confluence as a multiple state search, and then enter Missouri here, select all the ones that I want, and I can download them like that. Super, super fast. You can also search for locations. You can search for 4-digit HUC codes, however you want to do it. I've selected those 3. I'm going to go with that. That's good. Now we're going to give you a summarization. Do you actually want these stations? This is your last chance to say no. I do want them. Click import. That actually downloads this information for me and adds it to my study. This has geographic information with it, so I can place it in the map, actual XY location, and I give a summary of this actual data. What I downloaded were both flows and codes. I can visualize both of those together. I select them both here, do plot, data plot, and now I can actually see there is a code 7 in here that's indicative of a historical event, so outside of the bounds of systematic data collection. That's what that means. I can plot a bunch of sites at once. So I'm going to select all 3 of those, do data plot. Now I get a plot of the actual data itself. If I don't know which one's which, I can click on a legend item, and it highlights that for me in the plot. Oh, that's agency. I got it. Oh, that's Sharp Station over here. It highlights it in the plot. If I would like to edit that data, I can go to Data, Tabulate, Edit, Allow Editing, and I can go through and edit that as well if I would like. Things that we've added since the last release for data visualization. Specifically, I want to call your attention to the year-over-year plot. So I get to that by right-clicking on a data set and say year-over-year plot. And now I have to demarcate what the year actually is. By default, we're going to select the October 1st through September 30th water year for you. You can also do calendar year, which is January 1st through December 31st, or you can enter something else, right? April 15th through the 14th of April. And then we build a plot for you where we throw away the year. We plot everything on an axis from 01 October through 30 September. This is really, really helpful for identifying seasonality, right? There's a significant cluster of annual peaks at this location from late spring through the beginning of the fall, something like that. There are a few peaks or annual maxima in the winter months, right? Maybe some in the middle of springish, something like that. So there's a pretty clearly defined season here. These might be indicative of a different flood generating mechanism. So maybe I want to do something different with that. I'll come back to that and show you another year-over-year plot in a second. Really, really nice to have that information there. I'm going to gather some more data. So I'm going to right click and say new, use import wizard. I'll leave this blank too. I don't need to enter a name for this one. I'm going to select DSS. So this might be a SWIMS server extract, right? Where I got information from my remote server and how I have a local DSS file that I would like to select from. I'm going to click the ellipses here, and that'll bring up a chooser where I want to go and actually get this data. I want to grab this from this input data file. I'm going to double click to add them to the panel down here at the bottom, and I know that works because I click on the plot button and I get a representation of that data. If you don't get anything when you click plot, you know that you didn't select it. Make sure you double click to add it down here that you actually want to add it. Click next, gives me a summary of this. So if this plot is really small, you can resize this window if you would like. You can also double left click in the gray space, and now you get a standalone plot. You can do that for any plot in SSP as well. So that's good. That's what I want. I click import. That's great. Now I added this data that also had geographic information system data with it, or it actually had XY information with it, so I can plot it on my map here. That's cool. I'm going to do one more, and I'm going to import this from Excel. So now I'm going to open up the wizard again, click next. From this one, I want to select Microsoft Excel, click next. Now I got to select the Excel file. So let's go and find that, and that's in this file right here. This will give me a layout of all the sheets that I do have across this top here. So say I had 10 sheets, I would see 10 sheets right here. I want to select the one that I want to import from. I only have one, so it's sheet 1. We'll go with that. I'll click next. Now I need to demarcate dates and times and values, right, for an actual time series. My dates and times are in column A, so I hit the drop down at the top and say, that's my date and time column. And these are the values in column B, so I'm going to hit that drop down and say, those are my values column. There's nothing in C, so I don't need to do anything over here. But I don't want date, and I don't want precip, space, parens, inch. So I'm going to right click and say skip cell. I'm going to say right click, skip cell. And I know that that worked because it made those cells gray. Dates and times should be in green. Values should be in blue. That looks great. Let me click the plot button to make sure that that was good. Everything looks great. I have no idea what that data is, so obviously the y-axis doesn't really have a great label with it, but the data is a time series, so that looks good to me. Click next. Now I actually give it DSS part names because we do save this as a DSS time series. And this is from the Feather River at Oroville Dam. And this is precipitation data. It recognizes that it should be 1 day. Yes, it is. It has a 1 day duration, and I'm going to give this an F part of Excel. It is in inches, and the type is period cumulative. This is typical precipitation data as well, so we're going to roll with that. I'll click next. Again, it gives me a summary. This is what you selected. Are you good with that? Yes, I am perfect with that. I'll click import. This didn't really have any GIS information with it, but I can give it that. I'm going to right click, say edit metadata. I'm going to say this is in latitude, longitude, is using the NAD 83 datum, and I'm going to give it degrees, minutes, and seconds here. This is -121.2900.5 and a latitude of 39 degrees, 32 minutes, 14.3 seconds. And that's where this is actually located. I know that that works. Go ahead and click maps, add internet map, and now I can see where this is in the world. Right? This is the Oroville Dam site out in California. I had 2 sites on the East Coast that I imported from North Carolina, and I have these 3 locations in Missouri as well. All right, I can also do year-over-year plots for precipitation data. I can do year-over-year plots for snow. I can do year-over-year for wind speed, for precip, whatever, right? Any variable works for year-over-year. This is great for identifying seasonality. It's relatively clear to me that, yes, there is a significant rainy season in California. We don't get rain from April-ish, end of April through the beginning of the fall or beginning of the winter, right? It's very, very, very dry. That is the way that that goes. I can clearly identify seasons there, which is nice. All right, now that I have data in, I want to do a couple of things in Bulletin 17. I'm going to show you how that works and the enhancements that we've made there to make your life easier. I'll right-click and I want to make a new Bulletin 17 analysis. And I'm going to call this one Agency Base. I'm going to select this data set, and this is the first one that I want, the Platte River at Agency, Missouri. That's great. I have buttons over here that I can quickly say, like, what was that data set again? Let me plot that. Ah, great. Cool. That is the one that I want. I want to tabulate it. I can make live edits over here as well. I would like to do that. We've added these 2 buttons over here to quickly identify the data set that you just selected as well. This panel is new, expected probability curve. I'm going to come back to that in a second. And we've also made enhancements to the use of weighted skew, or the use of a regional skew information as well. I will come back to that too. On the options tab, Avital is going to talk about variable time window. This is super powerful. Anticipate that one. It's going to be cool. I want to add a couple of ordinates on the output frequency ordinates panel. So I'm going to do insert row. I want just 2 ordinates here. Take things out a little bit to the 1 in 1,000 and 1 in 10,000 annual exceedance probability. If I go to the EMA data tab, there are 2 rows here that don't have any information. So these are perception thresholds at the top, flow ranges at the bottom. I cannot have nothing here. I have to fill this in, right? The easiest thing to do Is to say from 1931 to 1932, I have no idea what happened. So I'm going to double left click, right click, set as INF. We automatically fill out any new rows in the perception thresholds table as INF. So, or the high threshold is INF. So that's hopefully a time saver as well. What this means is I have a complementary flow range of 0 to infinity. We can do better than that, right? And all but the most simplest cases, we can always do better than that. And let me step you through how I would do that. I know that during this time period, the river existed, so there still was an annual maxima. What is a reasonable flow rate to say, like, if it were bigger than this, somebody would have noted it, somebody would have seen. I can go and look at a very large historic or very large event from the systematic time period, and that was 50,000 CFS in the year 1947. So you guys see how I did that? I can click in the plot, and I can go to that row in the table, right? So I'm gonna click on this one. What year was this? That was 1993. I remember that from when I was a kid. That was a huge event. Remember that going on. But from reading post-flood reports, I can tell that the 1947 peak of 50,000 CFS was a huge event. A lot of people got impacted by that. So it's reasonable for me to say, during those unobserved years, I would have seen something if it were bigger than 50,000 CFS. Somebody would have noted it, right? The river still existed, but the flow was somewhere in between 0 and 50,000 CFS. This is a reasonable thing to do. I'm going to click compute, and now I get a new curve when I click plot curve. You've seen this before. We show you the plotting positions, all these circles and squares, the plotting positions of the actual observed data. We computed we fit a log Pearson 3 distribution that's described by this red line right here. And we also give you confidence intervals as dashed green lines. But we added this plot panel here in the lower right-hand corner. If you don't like it, go ahead and hide it. It'll go away. If you want it back again, just plot it again. This is typical stuff that we want to show in an actual report, something like that. So why not add it to the plot itself? If you don't like it there, right click, edit properties, location. Let's just change that to top left, and it'll move it up there. You can move it where you would like it to be, whatever works for you as well. As you add complexity to your analysis, this will change. So if you have historical information, you'll see a row in here. If you have low outliers like we do, you see a row in here. That information will be added there. Let me turn on expected probability. Let's talk about that for a second. So I went back to the general tab. I clicked on compute expected probability using numerical integration. I click compute. And what we do here is we actually compute a ton of different confidence limits, right? I think there's a list of like 30 or 40 that we included in here. We actually integrate across horizontally to figure out what is the mean value as well. You'll see this warning usually when we have more exceedance probability ordinate specified than just the default, and also when we have some specifically shaped distributions as well. Don't worry about this. This just means that, hey, we encountered confidence limits that went like this and gave you a frowny face or something like that. That is possible with EMA. We just flatline them for these computations as well. We smooth them out a little bit. Click OK. That's all great. And now I have an additional curve on my plot, which is this guy, this expected probability curve. If you are doing a single simulation using these results, right, I want to figure out what is the 1 in 1,000 AEP inundation extent, right, using a single run in HEC-RAS. This is the value to use. You can find that on the tabular results tab. Let's go across that specific AEP. This value is my best estimate flow for that AEP, right? If I am using these results in FDA, in HEC-WAT, in RMC RFA, in a Monte Carlo simulation, I will use these parameterized distribution and I will use the parameterized distribution and the equivalent record length that's associated with that. The uncertainty is encapsulated within the actual Monte Carlo simulations. If you're doing one simulation and one simulation only, the expected probability curve is the one to use. This is an agency decision that USACE has undertaken. Not all agencies are the same. If you would like more information, here is where that webinar that I talked about earlier comes into play. Please check this one out as well. All right, for the sake of time, there are many other things that I would love to show you in Bulletin 17. Like the inclusion of paleoflood data. We can go back 10 million years in the past. If anybody has 10 million years worth of paleoflood information, let me know. You work with Keith to get that. I would love to be a part of that. Hit me up. But I want to give it over to Avital, and give her a chance to present.
All right, thanks, Mike. All right, so like Mike said, I joined HEC last summer. I haven't had a chance to interact with you yet. I hope that changes. I hope you reach out with tech support. And if you've got questions while I'm presenting, please put them in the chat. I can either address them as I'm speaking, or one of the other team members can get to them. All right, so I'm going to highlight one more feature in 17C, like Mike said, and then I'll talk record extension, which was a really big addition to version 2.3. So I already have this project set up. I've already imported some data like Mike showed you from USGS and from a DSS record. So no sleight of hand, I just followed the same steps Mike did. And I'll start with this first gauge, which is located on Bushkill in eastern Pennsylvania, the tributary to the Delaware River. I'm going to first show that to you. I've got 114 years of purely systematic data. So this is a nice gauge to use. And I'm going to create a bulletin 17C analysis. I'll call it Bushkill V17C, and I'll select that data set from my drop-down menu. So I don't have to enter anything on the EMA data tab because all of my data is systematic. I can roll with the default perception threshold. But on the options tab, I want to highlight this variable time window. This is a new feature in 2.3 funded by the Fort Worth District. So thank you to Fort Worth District. You've got two options for variable time windows. I'll show you both of them. The first is using a moving time window. So this will maintain the same window length, whatever you put in this first field, and just shift that forward in time by an increment. So I'll do 2 years. I'll compute that. So it's going to compute flow quantiles and distribution statistics for a 20-year period, right? So that'll start 1909 to 1928, shift it forward 2 years until I get to the end of my record. All right, when that's done, I get this variable time window results tab. I'll come here, make this bigger. You get tabular results as well as a plot. These are all my flow quantiles. I stuck with the default frequency ordinates. If you added ordinates, you'd get extra columns, right? So you can see how these quantiles change in time, right? So just as a reminder, this first set of quantiles here, if I drew a vertical line, those are computed using the 20 annual peaks to the left of it, right? So every single set of flow quantiles is computed using a 20-year period, right? And you can see how drastically those quantiles change depending on the magnitude of your annual peaks. So you probably noticed when I pulled up the annual peaks, I've got a flood of record here in 1955 that is 4 or 5 times larger than the next largest peak, right? So quite a bit different. Causes all my quantiles to spike. As Mike says, the quantiles are bumping here, right? And then they recede as I move back towards annual peaks that are closer in magnitude to what's typical. I can also show you the statistics. This is really cool. I like this a lot. You get tabular output again, as well as graphs. So just like Mike showed, you can double left click in the gray space of any plot in SSP, pop it out, make it bigger, take a screenshot, throw it in a report. Hopefully we've made that easier for you. So I'm showing the mean, standard deviation, and skew. This is just station skew. I'm not using regional. And as you see, there's some variability in my distribution parameters, right? Particularly in the skew. Depending on which 20-year period I use, I get a skew of -0.5 or +2. That's super positive. This is why we always want more data, right? All right, so I'll go back to the options. I showed you moving time window. Probably more common is the expanding time window. So I'm going to compute this. It'll take a few seconds to churn. So what this is doing is starting with the initial 20 years of data. So it'll be 1909 to 1928. And then for each iteration, we add 1 year of data, right? So I specified an increment of 1. So I'm going to eventually use all 114 annual peaks, but I'll compute the data from 20 years, 21, 22, et cetera. If you specify an increment that doesn't evenly divide into your record length, that's okay. SSP will just throw you a warning, and it will use a shorter increment for that final computation. All right, so we'll spin for a sec. Takes longer on a webinar than when you're doing it on your own computer. And I'll go back to that results tab, and let's start with the flow, right? So like I said, flood of record 1955 is quite a bit bigger than all the other annual peaks. So I get a major increase in all of my quantiles, and then they slowly start to recede as my annual peaks tend to be in the more typical range. So it shows if you did a low frequency analysis before the flood of record and after, you get really, really different results. This is also really useful if you have to redo a planning study, or maybe you're asked to revisit an analysis, right? And someone remembers, maybe you're at a public meeting and someone remembers that 20 years ago when you did this study, your 1 in 500 flow was 20,000, and now it's 17,000, right? This is a really powerful plot that you can pull up and show why that's true. Same thing with the statistics. As we increase our record length, right, we move to the right, our distribution parameters tend to stabilize a bit. That's not always the case, especially with skew. In this case, flood of record, we see a huge increase from about 0.6 to 1.8, and then mostly stabilization after that, right? So this makes a really strong case. One, for getting more data, which I'll talk about next, and two, for incorporating regional skew, right? We want to stabilize the skew estimate as best as we can, right? You may not have 114 years of data, you likely don't. But now I'm going to talk about record extension. So how can you actually get more data at a short record site? I'll close out of this. All right, so common problem in hydrology. I'm holding the control button, and I just clicked on 2 records, and now I'm going to plot. That's not the common problem in hydrology. The common problem in hydrology is that you're often asked to analyze a site like the one shown in blue, right? That's got not that many annual peaks, right? A relatively short record. And it would be great if you could analyze the record shown in red, right? You've got 80 some annual peaks here, nice long record, but not at the site you're being asked to investigate, right? So the question is, can I leverage the information I have at the Kings River site, the one shown in red, to increase the information I have at the Long Creek site? And the answer is yes. With some additional information, right, with high enough correlation, you can do that. It's often called two-station comparison, or we call it record extension. So this is a completely new analysis type in version 2.3. I am also a right clicker, but for those who are not, I'll show you how to get to it. From the analysis tab, you can select new and then select record extension at the bottom. All right, so I'm going to try and extend the Long Creek record, and I'll explain what move means. So before you do anything, you want to consider what type of data you have. So I have annual peaks. They happen to be instantaneous. If I have any type of annual peak that I'm going to use for a frequency analysis. So that means instantaneous peaks for bulletin 17C, end day duration, right? So that could be 1, 3, 7 day, whatever duration for a volume frequency. You want to use move 3. Okay, so that's maintenance of variance extension. That's what the acronym stands for. If you're doing that, you want to make sure your data type is annual maxima, right? I've got a single value per year. If you are trying to extend a continuous record, so the most common example is continuous daily flow. Let's say you have a 30-year record and you want to get more data out of that for use in a flow duration analysis or a low flow analysis. You want to use move 1, and then you would select regular as the data type, right? That's many data values per year. So I've got annual peaks. I'm sticking with move 3. This panel becomes visible, and I'll use the default, which is use the most recent years. So that means when I compute my regression, it will extend the most recent years in my record. And I'll show you that when we get to the results. All right, so now I have to tell SSP, which is my long record site and which is my short record site. So I'm going to select Kings River. That is my long record site. And then Long Creek is my short record site. We give you this button, make it handy just to make sure that you are selecting the right sites. So you might have many, many data sets here, and you want to make sure you're selecting the right one. So I pulled up the plot. My long record site is Kings River. That's blue, so I got that right. And Long Creek is red. That's my short record site. So that looks good, right? So what I'm, just as a reminder, I'm trying to see, can I add more information to this red time series, given that I have many, many more annual peaks in my blue time series. All right, so on the right here, you get some additional panels. You could restrict the date range if you want. You can specify a different year specification. I'm going to roll with October 1st as my water year, and you can change the output labeling if you want. All right, I'll select the data tab, and this computes some stuff on the fly for me. So top table is my complete record. So at both sites, how many annual peaks do I have? Got 26 at Long Creek, 85 at Kings River. This will compute the log Pearson 3 distribution statistics for me, so you can take a look at them. Second table is the concurrent record, right? So in this example, my concurrent record happens to be the complete record at Long Creek, right? So for every year that I have data at Long Creek, I have a value at the Kings River site. So my distribution parameters for the concurrent record happen to be equal to the complete record here, but that's not true for Kings River, right? This is just the parameters fit to 26 annual peaks. And then on the bottom table, I have the non-concurrent record, right? So nothing for Long Creek, That's fully covered by the complete record. And then I use the 59 remaining peaks at the Kings River site to compute those statistics. That's just some information for you. You get a plot here of the concurrent record, Kings River, and Long Creek annual peaks shown in log scale. All right, so I'm going to compute. If you do that, you should see a nice red line that appears. That's my fitted model. I'll go to the record extension tab, and these are your results. So I'm going to walk you through everything. The table, you'll see the long record site annual peaks. So that's this first column. That's also shown in the plot here in green. The second column is my short record site. So if I scroll to the most recent years, that's probably where you have your original data. That's not always true, right? You might have a data that had, a gauge that had 20 years of data from 1960 to 1980, and then it was discontinued, right? So you have to scroll and find the blue text, but these are my original annual peaks at the short record site before I did any record extension. And they're also shown in blue here. And then what I've done is I have extended the complete record for the full length of my Kings River site, and those computed values are in red. There's a catch in how Bulletin 17C implements move 3, and I'll talk about that. So there's this parameter that's computed, n sub e. This is the number of years that you are allowed to extend your record. So we actually compute it twice. If you see it twice and you're confused, this is why. It's associated with the two estimators, the Metalis-Jacob mean and variance. All you need to know is that the one associated with the variance is always going to be smaller, and so it governs. So this is what we use. We'll round this down for you to 27. So you get 27 extra years of data, which is super cool. I'll show you that in a Bulletin 17C analysis in a minute. So because I selected use the most recent years, SSP is going to very nicely check the 27 most recent years of extended record, right? So I go all the way back to 1970 now. That's pretty sweet. I was missing 2 annual peaks here in 2000 and 2001. So that's 2 years plus 25. All right, so I like how this looks. We give you this nice red button. This is a red button that you can actually push. So I'm going to save the extended record to a new data set. We'll add extended to the name. I'm going to keep the default. So let's click next. Same thing as before. You can make this bigger, or you could double left click and pop this out. All right, I'm going to click import, and then I'll close out of the record extension. We do have tutorials on move 1 and move 3. I know this is kind of fast. We do a whole lecture on this in the flow frequency. You can always shoot us an email, post on Discourse if you've got any questions. All right, so I'll show you how powerful this is now. You should do record extension absolutely everywhere you can. The red is my original data. I had something like 26 annual peaks. My extended record is in blue. I think I have 53. So I have literally doubled, or just about doubled, my record, right? That is extremely powerful. I'll show you how powerful it is in a Bulletin 17C analysis. So I'm going to select the original non-extended record. I'll have to go to EMA, and now I need to actually add a perception threshold since I'm missing 2 years. So I have an estimate for the 1927, the Great Mississippi Flood of 1927, corresponding to this discharge. So I'm choosing to use that as my perception threshold. We can have a whole discussion about perception thresholds another time. That is the most commonly asked question we get. And I'm going to compute that. And I'll make you wait in suspense to show you the results for another minute. Oh, let me actually show you this. So I can save this analysis as a copy. And I'm going to use the extended record now. So let's add extended to the name. Double click. And now I'll select the extended record. Now here's a trick. Because I did a save as, it's using the same perception thresholds. So right now SSP is only actually using data from 1995 to 2022. I don't want that. I have a complete systematic record now. So I'm going to clear the second row. And then I'm going to change the start year to 1970 to make sure that I actually use all that extra data that I computed. So I'll make sure that's cleared. Yep, plot looks good to me. And now I'll compute. All right, so last things I'm going to show you, make sure we leave time for questions. I can control and click both data sets and then go to results and click summary report. And this stacks the results on top of each other. So that's super cool. You can see how the distribution parameters change as I've added more data. I want to call attention to this ERL, the effective record length. We had 26 systematic events in my original record, I had 2 sensor data, or 2 years of sensor data. So I got an ERL of 27, right? I get some additional information from those 2 years of censored data, but they're not equal to 1. By using record extension, I now have 53 systematic events. That gives me an ERL of 50. There was a low outlier, so I kind of get knocked down for that. But right, I've added 23 years of information content in 5 or 10 minutes, right? So this is super powerful. We've been telling everyone do this for every study, right? The only reason you shouldn't use record extension is if you have the longest record site around, right? Otherwise, we give you a correlation analysis. I don't think we'll have time for that, but we do have tutorials which show you ways that you could pull in data for 5 gauges, and you could figure out which one has the highest correlation with your short record site and which is the best candidate to use as a record extension. Last thing I'll show you is the 2 plots. So a lot of lines on this plot. This one is the extended curve, right? You can click in the legend, and this is the original. And then what you'll notice is that my confidence intervals also change, but as I extend my record, right, I add more information content, my confidence intervals actually become less wide, right? They're narrower now, which is really important, right? We want to decrease the uncertainty in our fitted distribution. Hopefully I made it clear why you should use record extension, and I've been seeing some questions in the chat. I think we'll set aside the last 10 minutes or so for questions.
Yeah, we did have some questions come in. And you actually answered the last one. Thank you for that. About checking the degree of correlation between the short and long record for the concurrent years. That is key, yes. Bulletin 17C stipulates that you should use a short and long year or long record site that have a correlation coefficient greater than 80%. However, we do let the computations proceed if you have less than that correlation coefficient for the concurrent years, or the computed correlation coefficient is less than 80%. But you do get a warning about it. We just let it keep going. User beware for that one.
Can I add something, Mike?
Yes.
This is Beth Faber. What happens when your correlation is lower is that the number of years of equivalent value of extension will be lower. So like if you have a terrible correlation, it'll say, oh, you can only extend 1 year. So it won't do much for you. Whereas when your correlation's quite high, your equivalent increased information is much higher. And then it'll have you extend more years. So you can't get in too much trouble, but it's still a very good idea to check correlations first and see which is the best and whether this is worth your time.
Yeah, I forgot to mention that I had a correlation of 0.934. That's high. I spent a lot of time vetting that, and I got 27 years of added record. If I had a correlation of 0.8, that would definitely not be 27, right? It might be something like 20. So like Beth said, we won't let you go off the rails too much, but it's worth spending the time so that the time you spend is worthwhile in extending your record.
Do you want to talk about the tutorials and guides for record extension? I know we can't get to them right now, but
sure, yeah. So unfortunately, I can't post links because, like we said, Confluence is down. Like Mike showed, if you go to help tutorials and guides, it won't work right now, but hopefully soon you will be able to get to them. I can speak a little bit to them. So we have tutorials for Move 1 and Move 3 record extension. I think both were written by folks at districts. So I know Katie Cephas wrote one for Move 1 that extends mean daily flow for inflow into a reservoir, right? And then Move 3, I think we have for some gauges along the Columbia or one of the tributaries, right? And we do a correlation analysis with that. Correlation analysis can also be used for if you are assessing something for coincident frequency. So I'll talk to this really quickly, but this is one of the tutorials we use. We're using annual max precipitation on the interior of a levee as kind of an indicator of runoff. And then we want to evaluate whether the Columbia River stage that flows along that levee can be considered independent of the runoff, right? So we want to know whether these variables can reasonably be modeled as independent or not. And so I just load both of those up. I've got a coincident in time selected as my computation method. I'll talk about coincident events in a minute. And I've already computed this, but what I find is that my correlation is pretty low, which means I can say that these are independent. The other option you have in here is coincident events. That's what you would use if you are looking at a bunch of gauges, all with annual peak flows. and you want to know whether they are correlated with each other, right? So annual peak at a gauge in 1 year might not correspond to the annual peak at a nearby gauge, right? They might happen 6 months apart from different events. And so this can be used to assess the degree of correlation, and then you can choose the best candidate to use in a record extension. So I did that off screen. That's how I got my 2 gauges in Arkansas that I used for the record extension here. So hopefully you can get to those tutorials soon.
Yes. Sorry for the outage. That is unfortunate. We're working on it as we speak. So Zach, as soon as Confluence is back up again, keep trying. You'll be able to get there. Use our PowerPoint that we sent out. There's a whole bunch of links there as well. You can also go to the Help, Tutorials, and Guides menu option that Avital just talked about, and that'll take you to the location where the correlation and record extension tutorials are located. Let me get to Stephen's question in a second, but let me go back to Beta's question to start with. He was asking if we plot the confidence intervals on the expanding window computations. So I answered him in the chat, but I'll say for everybody else, we struggle with this one. We went back and forth on this. So typically we plot the median or the computed curve, upper and lower confidence limits, and we can also plot expected probability as well. When you have like 9 or 8 different output frequency ordinance and 4 different curves, it starts to be like crazy plot, right? We toned it back a bit and we just went with the median curves to start with. If you are interested in enhancing this, consider this the first rollout of this tool, right? If you would find benefit to additional information being included in those plots, and you want to partner with us to add that as an enhancement, hit us up, come talk to us. We can work together to make that happen. We do plot, or we do tabulate that within the report tab, so or report file. So if you're interested in all that information for all the individual time windows, we do provide that information for you. We just don't plot it. All right. And Stephen, Beth, do you want to speak to Stephen's question?
I put an answer in the chat, but it's kind of addressing what we said out loud earlier. But if the correlation is lower, the equivalent extension value will be lower, so you'll extend fewer years, and the confidence intervals therefore won't narrow as much as if you were able to extend more years.
Yes. One key consideration about this is that we treat those extended years as perfectly known, right? They are exactly known systematic observations, right? There is no uncertainty that's associated with that. We all know that they're uncertain extensions, right? We are working on ways to address that in the future. That has been a topic of conversation for quite some time.
Part of that is, I want to say part of that is captured in the fact that we're only extending that number of years. So maybe there's 52 years that could have been extended, and the best frequency curve would result from having extended all 52 years and having the largest sample, and that's your frequency curve that will be the most accurate. But it will also be based on too many years of supposedly perfectly known data, so your confidence intervals will be too narrow. And the idea of computing that equivalent extension value is so you don't extend more years than you should based on how much information you really have gathered. So you don't get to extend all 52. I'm making up 52 because I don't remember what the number was, but maybe you only get to extend 27 instead of 52. And so then your confidence intervals will be more correct based on what information you really did get, or the value of it.
Yes,
hopefully you get about the same frequency curve if you chose the match skew option.
So Beth made this method. If you would like to know the ins and outs of how it works and all the nuances to it, you have the expert on this method right here at your fingertips. Beth is.
Well, I know the person who made the method.
Well, it's giving you all the credit, Beth. Come on. But yes, Beth knows this better than most anybody else. So feel free to hit her up with some good questions about record extension. And also if you have ideas for how to improve this in the future, we're up for discussion as well. All right, Beta asked if there's any plans to add tools to detect non-stationarity or change points in the data as part of like the climate change tools, the chat tools as well, Beta? Is that what you were asking about? If so, those tools stand as they currently are and allow you to do the requisite amount of analysis. We are interested in doing something similar, so keep your eyes out for future offerings on that. We'll try and be a little bit discreet in my description on what we're going to do there, but yes, we're thinking about it. Thank you all for attending our webinar today. Thanks for the great questions and interaction. Please reach out with any questions you may have as you use HEC-SSP. Have a good day.